Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here we discuss series and figure eight numbers. So in engineering especially, it is important to familiar with the different series and or sequence as well as classification of numbers and different types of numbers for the enhancement skills in mathematical skills in the enhancement, especially logical thinking. So we have Fibonacci sequence, a sequence in which the sum of the preceding two numbers, the current number is the sum of the preceding two numbers, and it begins with 1 1, then 2, then 3, 1 2 3, then 5, then 8, and so on and so forth, as long as it satisfies this definition. So 1 1 2 3, because 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 13, 8 plus 13 21, 13 plus 21 34, 21 plus 34 55, 34 plus 55 89, and so on and so forth. So that's Fibonacci sequence. It is important to remember the first three numbers, and based on the definition, you must be able to expand Fibonacci sequence. Next is local sequence, same in principle as that of the Fibonacci sequence. It's except that the first three numbers are 1 3 4. So 1 3 4 7 11 18 29. So that sequence. So 1 3 4 7 11 18 29 47 76 47 plus 76 123, and so on and so forth. So same in principle. So 1 plus 3 is 4, 3 plus 4 7, 4 plus 7 11, 7 plus 11 18, 11 plus 18 29, 18 plus 29 47, 29 plus 47 76. So that's why the next is 47 plus 76 123 in that sequence. Then triangular numbers. These are figure eight numbers. This is the series of numbers which represents the number of identical objects needed to arrange them in a triangular manner, equilateral triangular arrangement, just like piling billiard balls. So this is actually the sum of counting numbers, and in future engineering and finance applications, economic engineering economy applications, uh, we use this in adding counting numbers or sum of the year's digit. So this sequence is also the sum of the digits of counting numbers. So 1, 3, 6, 10, 15, 21, 28, 36, 45, 55, 66, 78, and 91, and so on and so forth. And it has this formula here, n over 2 times n plus 1, which is the sum of arithmetic sequence, arithmetic progression, the sum of 1 plus 2 plus 3 plus 4 plus 5. So 1 plus 2, so 3 plus 3, 6. Next is plus 4, 6 plus 4, 10, plus 5, 15, plus 6, 15 plus 6, 21, plus 7, 21 plus 7, 28. 28 plus 8, 36. 36 plus 9, 45. 45 plus 10, 55. 55 plus 11, 66. 66 plus 12, 78. 78 plus 30, 91. 91 plus 14, 105, and so on and so forth. So this is the formula, and we can derive this in arithmetic progression later as one topic in algebra. So to figure out that when you arrange identical objects like piling billiard balls, the topmost object is 1, and the next would be, we have the next layer has 2 balls, so 1 plus 2 is 3. The next layer has 3 balls, so that's why 3 plus 3 is 6, and so on and so forth. So in that arrangement, so 1, then 3, then add 3, 6, then add 4, 10, then add 5, 15. So I hope that you know the concept. Gnomons, on the other hand, is actually odd numbers. So, but this is a figure 8 number which determines the number of objects when arranged in different directions but of equal number. So first at this corner 1, 1 in that direction and 1 also in that direction. Then if you have 2 objects here, 2 objects in that direction. So if you expand, that's 1, 3, 5, 7, 9, 11, 13, 15. Actually odd numbers. In general, the formula is 2n minus 1. Then oblong numbers, a figure 8 number in which it is the number of identical objects when arranged in a rectangular manner such that the dimension of one is 1 greater than the dimension of the other. So such as 1 by 2. So 2, it begins with 2. 2 by 3, 6. 3 by 4, 12. 4 by 5, 20. 5 by 6, 30. So that's the arrangement. So again, we go back to Gommon's, a sequence of numbers representing the number of identical objects when equally arranged along the perpendicular legs of an isosceles right triangle. So these are actually odd numbers. So 2n minus 1 in general. Then oblong numbers, I already explained. So 2, which is 1 by 2. 6, which is 2 by 3. 12, which is 3 by 4. 20, which is 4 by 5. 30, which is 5 by 6. 42, which is 6 by 7. 56, which is 7 by 8. Then next is 8 by 9, 72. Next is 9 by 10, which is 90. Next is 10 by 11, which is 110, and so on and so forth. And the formula is n times n plus 1, the number, any number here. So for example, when n is 11, so 11 times 12, that's I think 132. So that's it. So 30 means 5 times 5 plus 1, so 5 by 6. So that's the fifth oblong number is 30. 5 times 5 plus 1. Next is perfect squares. Of course, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100, 11 square 121, 12 square 144. So in general, n square. So obviously, arrangement in square form. So there's no need to have the figure because these are known squares, perfect squares. Cubical numbers like number of objects, identical objects, and decide to arrange them in cubical shape. So these are 1 cube, 1, 2 cube, 8, 3 cube, 27, 4 cube, 64, 5 cube, 125, 6 cube, 216, 7 cube, 343, 8 cube, 512, and so on and so forth. So in general, n cube. So self-explanatory. You're just familiar with perfect cubes. Tetrahedral numbers. Figure 8 number. A figure 8 number in which it represents the number of identical objects necessary to arrange them in pyramidal tetrahedral manner. So the topmost object is 1 and it is placed over 3 objects. Then the 3 objects is placed over 6 objects, triangular form, which are the number of objects in a layer are triangular numbers also. So let me demonstrate or illustrate it here so that you can have an idea about tetrahedral numbers. So 1, 4, 10, 20, 35, 56, and so on and so forth. And I derive a formula which is applicable only when n is greater or equal to 3. So this is the first number. N is 3. For that case, n combination 3 using your calculator is 1. But take note, this is the first tetrahedral number. And I use 3 here instead of 1. So therefore, in general, the nth tetrahedral number will be always plus 2. So for instance, 10. 10 is, this is the third. So 3 plus 2, because this is the third position, 3 plus 2 is 5. So 5 combination 3 will give us 10. So if it is 2, 4, 6, if this is the 6, then plus 2, 6 position, 6 tetrahedral number plus 2. So use 8C3 and you can compute it is 56. So to illustrate, this is the topmost object placed over 3 objects. I hope you can imagine. Then the 3 objects are placed over 6 objects arranged in triangular manner. The 6 objects are placed over 10 objects. Take note that the number of identical objects in each layer are triangular numbers. 1, 3, 6, 10. So next is 15. Next is 21, and so on and so forth in that manner. So that you can expand tetrahedral manner, tetrahedral numbers. So 1 plus 3, 4, plus 6, 10, plus 10, 20. Next is 15, 20 plus 15, 35. After 15, 21. So 35 plus 21, 56. After 21, 28. 56 plus 28, 84. After 28, 36. So 84 plus 36. 84 plus 36 is 120, and so on and so forth. So that's it. That's tetrahedral number. Tetrahedral numbers. So the number of object here in the topmost layer is 1. Then followed by 3. So 1, 3, then 6, then 10. Next is 15. Take note that these are triangular numbers. 1, 3, 6, 10, 15, 21, 28, 36, 45, and so on and so forth. Next is square pyramidal numbers. So just like this, except that the number of identical objects in each layer are perfect squares. So 1 is placed over 4, 4 is placed over 9, 9 is placed over 16, 16 is placed over 25, 25 is placed over 36, and so on and so forth. So sequence of numbers in which any number in the sequence corresponds to the number of identical objects arranged in a pyramidal form with a square base. So that's why it is 1, 5, 14, 30, 55, 91, 140, 204, 205. Take note the difference is 4, which is 2 square. 14 minus 5 is 9, which is 3 square. 30 minus 14, 16, which is 4 square. 55 minus 30 is 25, which is 5 square. 91 minus 55 is 36, which is 6 square. 140 minus 91 is 49, which is 7 square. 204 minus 140 is 64, which is 8 square. 285 minus 204 is 81, which is 9 square. So next is 10 square, so 385 would be the next number here. So 1 is placed over 4, 4 is placed over 9, 9 is placed over 16, 16 is placed over 25. So that's it, and so on and so forth. So the number of objects in the topmost layer is 1. So this is square pyramidal. So 1, then 4. So that's why 1 plus 4 is 5. Next is 9. That's why 5 plus 9 is 14. Then 16. Take note, these are perfect squares. That's why 14 plus 16 is 30. Next is 25. So in that manner, I hope that you get the idea. So let's have problems for discussion and solutions. Example 1, what follows logically in the series of numbers below? So the technique is, if you cannot see the pattern, you get the difference between adjacent numbers. Like, for instance, in this case, 1, then 21 minus 16 is 5, 35 minus 21 is 14, then 30, then 120 minus 65 is 55. Then observe that these are square pyramidal numbers. So if you're still unfamiliar with it, get the difference further. 4, 9. So 4 is 2 square, 9 is 3 square, then 16 is 4 square, 25, difference between 55 and 30 is 25, which is 5 square. So the next is 6 square, which is 36. So 55 plus 36 is 91. So that's why if we denote the missing number as x, then x is 120 plus 91. Take note, 91 minus 55 is 36, and it is 6 square. 55 minus 30 is 25, and that is 5 square. 30 minus 14 is 16, and that is 4 square. 14 minus 5 is 9, which is 3 square. 5 minus 1 is 4, which is 2 square. So perfect squares, difference between this. And however, these are square pyramidal numbers. So x is 120 plus 91. So x therefore is 211. So that's it for this problem. Second example, find the missing number in the series 72, 73. So it seems no pattern, but the technique is get the difference. So 1, then 3, then 6. So I think you are familiar with this. These are triangular numbers. 10, 15, 21, 28. Then between this missing number and 192 is 36 supposedly. Let's call that x, then 36. Then after 36 plus 9, 45. So that's why 237 minus 192 is 45. That proves that the difference between adjacent numbers are triangular numbers. Therefore, this missing number x is 128 plus 28. So it is 156. So that's it for problem 2, example 2. Next example, what follows logically from the series of numbers 121, 130, 146, 171, 207, blank. So get the difference, 9. 9 is, next is 16. So I think you're familiar with it. 3 square, 4 square. So next is 5 square, 25. 120, 171 minus 146 is 25. So that's 5 square. So 207 minus 171 is 36. And that is 6 square. So next is 7 square, which is 49. Therefore, if we denote that by x, x is 207 plus 49, and it is 256. Example 4, find the missing number from the series of numbers. So, difference between 17 and 18 is 1. Next is 3. Next is 4. So, 1, 3, 4. You're familiar with that. That's local sequence. So, next should be 7. 32 minus 25 is 7. So 4 plus 7 is 11. So next difference between this missing number and 32 should be 11. Therefore, if we denote that by x, that's 43. After 11 is 7 plus 11, 18. So 43 plus 18 is 61. So that checks. Therefore, the missing number is really 43. What is the 12th tetrahedral number? So remember, tetrahedral number is a series of number representing number of identical objects arranged in pyramidal form. So it begins with 1 over 3. So 4. 3 is over 6. 10. So 1, 4. 3 plus 1, 4 and 3. Then 6. 4 plus 6 is 10. Then after 6 is 10. So 10 plus 10, 20. After 10, the next triangular number is 15. So 20 plus 15, 35. After 15 plus 6, so 21. The next triangular number is 21. 35 plus 21 is 56. After 21 is 28. 56 plus 28 is 84. After 28 is 36. 84 plus 36 is 120. After 36 plus 9, 45. 120 plus 45, 165. After 45 plus 10, 55. 165 plus 55, 220. After 55 plus 11, 66. 220 plus 66, 286. Then 66 plus 12, 78. 286 plus 78. So x is 286 plus 78. So x is 364. And I developed a formula for tetrahedral number applicable when n is greater than 3. It was n combination 3. But n is not 12 here. Remember, plus 2. Because it begins with 3. Not the first entry, for example, is 3C3. So it is always plus 2. So if this is the 12th tetrahedral number, if you use the formula, it is 14 combination 3. So x is nc3 when n is greater or equal to 3. So if it is the 12th tetrahedral number plus 2, so n is 14. So x is 14 combination 3, and it will give us the same answer of 364. So that's it for this example 5. Example 6, what is the 18th triangular number? So remember, triangular numbers, number of identical objects when arranged in triangular manner. So 1, 3, 6, 10, plus 5, 15, plus 6, 21, plus 7, 28, plus 8, 36, plus 9, 45, plus 10, 55, plus 11, 66, plus 12, 78, plus 13, 91, plus 14, 105, plus 15, 120, plus 16, 136, plus 17, 153, and this is the 18th. 153 plus 18 is 171. So x is 153 plus 18, so it is 171. Or using the formula n over 2 times n plus 1 for the triangular number, substitute 18 here. So x is 18 over 2 times 18 plus 1. So 9 times 19, it is 171. Then lastly, example 7, what is the missing number? So the difference, 49 minus 24 is 25. 85 minus 49 is 36. And 134 minus 85 is 49. So take note, this is 5 square, perfect square. So 5 square, 6 square, 7 square. So the next is 8 square, 64. So if we call that x, x is 134 plus 64, and it is 198. Then for your part as viewers of this video, I hope so that you can also practice and test your understanding of the concepts discussed in this video, so that you can also develop your thinking skills, logical skills needed as a science student or science and technology student, or you may be an engineering and architecture student in the future, or you like mathematics, but this is purely for engineering mathematics, not for uh, pure mathematics. But you can also learn from here. So what is the missing number? PC4 62 89 153 blank. Pause the video, answer, analyze, then after answering, check the answer later. Do not uh, forward it. Next problem is, what is the missing number? 59, 69, 84, 105 blank. So I leave that to you. The first problem should have an answer of 278. The second one is 133, and this is the third. So what is the missing number? Pause the video, answer the problem. When you have an answer, that's the time you check the answer, if your answer is correct. So that's all for this video. I hope that you like this video 4 and you learn also something from this video.